James S. Robbins designed and manufactured the first commercially successful hard rock tunnel boring machine, or TBM, more than 50 years ago, and the Robbins Company has been continually improving the design ever since. In fact, today, Robbins holds all high-performance world records for open hard rock TBMs. This video explains how hard rock is excavated with Robbins main beam TBMs and why they are the tool of choice for contractors worldwide. Robbins TBMs range in diameter from 3 to over 14 meters. The front of the tunnel boring machine consists of a rotating cutter head in which disc cutters are mounted. The cutter head is supported by a main bearing. Robbins main bearings have the largest bearing to tunnel diameter ratio in the industry. This results in superior bearing life when cutting hard rock. The cutter head holds disc cutters, which consists of a shaft, bearings, seals, and a rolling hub. The disc cutters are not powered directly. As the cutter head turns, the disc cutters roll when they make contact with the rock face. The cutters roll in concentric circles. As the force on the cutter head increases, the rock beneath each cutter is crushed and fractured. Eventually, these fractures meet, and rock chips, or muck, break away from the tunnel face. This process is known as kerf cutting. Buckets in the rotating cutter head scoop up muck from the bottom of the tunnel. As the cutter head rotates, gravity pulls the muck from the buckets and deposits the excavated material onto a belt conveyor inside the main beam. The muck is then transferred to the rear of the machine for removal from the tunnel. Eventually, the disc cutters wear out. Cutters can be replaced from the front or the back of the cutter head. The Robbins TBM offers unique cutter head efficiency. Hard rock cutter heads can vibrate intensely during operation. The Robbins TBM provides hydraulic bracing which expand radially to significantly reduce vibration and disc cutter wear. In addition, Robbins hard rock cutter heads are significantly deeper than the industry standard, further enhancing the rigidity of the structure and rock cutting efficiency. The force which thrusts the cutter head into the rock face is provided by multiple propel cylinders which are mounted to gripper shoes. The gripper shoes are firmly anchored in place by gripper cylinders, which push the shoes outward against the tunnel wall with tremendous force. The gripper shoes provide the reactions base for the propel cylinders. A TBM boring stroke is completed when the propel cylinders are fully extended. At this point, the TBM must be regripped. To do so, the cutter head must stop rotating. Then, rear legs are lowered to support the machine's weight so that the gripper shoes can be retracted from the tunnel wall and pulled inward. The propel cylinders are then retracted, which advances the gripper carriers and shoes. The gripper cylinders extend the shoes outward, once again anchoring them against the tunnel wall. Finally, the rear legs are retracted and boring can resume. The floating gripper system created by Robbins using a sliding trunnion mount allows the TBM to be continuously steered while boring. This superior system allows for precision steering adjustments and results in a more accurate alignment and a smoother tunnel face. Proper support of the rock as the TBM advances is critical to the safe construction of a tunnel heading. Robbins provides a variety of mechanized devices to assist in rapid, comprehensive ground support. Rock bolting is quickly and safely achieved by the use of Robbins custom-designed drill fixtures. Drilling takes place primarily under the protective canopy of the shield fingers, supported by previously installed bolts. A wire mesh erector provides for quick placement of large panels of welded wire fabric. A ring beam erector assembles, correctly positions, and expands a multi-piece ring beam, all within the protection of the shield finger. In some cases, remotely controlled shotcrete robots are the best solution for ground support in fault zones or highly fractured rock. These robots facilitate the controlled and rapid application of shotcrete at a minimum of time and cost. Probe drilling can detect the ground conditions ahead of the TBM, such as fault zones or water. Probe drilling is typically performed to distances of 30 to 60 meters ahead of the machine. If weak ground is found, it can be pre-grouted to increase ground stability. Robbins TBMs can be designed with some or all of these ground support components to optimize boring in a variety of ground conditions. In all cases, Robbins TBMs maintain the highest quality standards in the industry, resulting in rugged machines that create the longest tunnels in the hardest rock. Robbins, the most trusted name in tunneling.